This is the demonstration of the lunar lander trained with a population of 100 over 1,000 generations. When I run the rules and play the game, you'll see the final score appear on the right here. It varies quite a bit because a different environment is randomly generated each time. Some it works well, some not so well. So let's see how it goes. There we go, a reward of 35. Not great. Obviously it loses points for crashing or landing too hard. It gains points for landing in between the two flags. If it lands with 0 speed in between the two flags, I think it gets about 300 points. It also loses points for every time it fires the engine. Let's see how it goes this time. Oh, slightly negative. Okay. Okay, 223 this time, that's pretty good. $239. I think it scores more points for staying between the flags as it descends. I've also noticed once it lands it uses its side rockets to make sure it's in between the two flags, which is probably going against the intention of the game, but is allowed by the physics engine, so that gets a reward of 281. When I first started training it, for the first quite a few generations, it found the optimum. It found a local optimum of not firing the engines at all and just crashing as quickly as possible. Because if you're going to crash and get penalised for that, you might as well minimise the amount of penalty you get for firing your engines. So it took quite a while to get over that minima. Okay, that's a pretty good landing. Let's try one more. It does have trouble if it starts tilted at too high an angle. It struggles to right itself. That's quite a good landing, 249. So the entire AI is encoded in these fuzzy logic rules. So you have 7 observations that are the inputs given to you by the environment, and you have 2 actions which are floating point values. So I think 0 is firing the main engine, and action 1 is firing the side engines. So a negative value fires to the left and a positive value fires to the right. So that is it.